So I'm going to be talking about building large-scale applications using web standards. And I guess the best way to think about this, well, the way I've thought about it is I've been working for a print company out of New Braunfels, Texas. If you own a checkbook, the odds are about 50% that they printed it. And as part of their checkbook business, they're actually branching out into business cards, office-related printables, but also greeting cards, wedding invitations, and they're doing so in partnership with some brands that you already know, Walmart, Costco, Target, and others. And as part of that, we needed to improve the quality of our end-user editing experience on both desktop browsers and also mobile devices. And so part of this project was taking their existing application, moving it to HTML5, optimizing it for mobile, and optimizing it for desktop to provide the best experience no matter where you are. So over the course of the past 2.5 years, we have built 4 configurators, and each of those has released 3 times. So a lot of what we do is we have core technology that we rely on, and then we create configurators to solve the type of problem that we're addressing. And to kind of give you a flavor of it, this is actually one configurator, and I'll actually show you this working. It looks like a standard web page, but there's a substantial application sitting under this. What you see on the left, that is not an image. That is actually a rendering of an InDesign document that's been loaded from the server to the client. And the text fields, although they look really innocent as well, if you edit any of those, it live changes the text on canvas. But additionally, it also live edits an InDesign document that is backing this. So when you actually put something in your cart, you put an InDesign document in your cart. And so the editing workflow is intentionally simple for the end user. It is very fast loading, no side effects. Well, I'll actually load it and show you what it looks like. But there are 40,000 of these designs, and we test all those documents and the workflow to get that done. Additionally, this actually creates a physical stamp. It's not a printed product, but it is an engraved product where the surface you're designing actually becomes an inverted carving on a piece of plastic. And then that gets put onto a press, and you can basically stamp envelopes and the like. The other product that we've been working on for a number of years is actually, this is the print configurator. So we're actually in a wedding invitation, and all of the fields are editable. And as you can see, kind of basic editing controls and kind of layout. But if you resize this on a mobile device, on any type of tablet, it will just work. We're optimized to run everywhere, and that's kind of the nature of what I want to talk about is how we came to where we are, what we built out, and some of the problems we address, and actually how we address those problems. So let me actually show you what this looks like. And so this is expressionary, and I'll go to stamps. And I can pick a stamp. And there, the whole thing is loaded. It's done. So I can say Samsung DevConf. And any delay you see is actually my typing skills, not that of the configurator. So at the same time, we have this dynamic image that we've created on the client, but we also, in the background, we actually have a full InDesign document that's ready. If we add to cart, that basically goes with us. And then it becomes a print workflow from there, print ordering and laying this out and the like. So we can quickly go from simple data entry all the way to a cart and a checkout experience. Same is true on any phone, same is true on any tablet. And the reason that is because of the choice of web technologies we've made, and we've gotten very picky about what we do. The left is actually a canvas object, and that canvas object is rendered to very discreetly, only on changes. So anytime you type, we make character changes based on layout. We actually are laying out the text character by character and doing that in a way it's a little bit unique. But it's required for this particular client because the definition of large scale gets a little bit funny. You can either be large scale in terms of how many users you have, how much data is being pushed through a service, but in our case, it ends up being how much money is being pushed through the service because 90% of the orders occur within a 1.5-month window starting in about a week and ending just shy of December 20th. So if you think about 90% of your business happening in that short of a window, you'd want it to be right. So next up is actually Walmart Stationery. So we've been building out in partnership with Walmart, but you can load any of these documents. And this is actually the full print configurator. So I basically just load it up, loads all the fonts, loads all the graphics, and everything is editable. But not just editable, it's actually you can zoom in on it and kind of get the fidelity. So what you're seeing is actually, I mean, this is design tool quality, but on a page. It's an application. It's not, I mean, it's not a web page. It's really an application embedded on the page. And the quality of the layout and the rendering, everyone's very particular about the quality of text, the kerning that goes into the text, making sure that it looks, the fidelity is right from when the user sees it in the browser all the way to when it gets printed and shipped to a customer. So let me talk a little bit about how we did this. So we have one code base. We have one code base and one app, and that one app basically detects what environment it is being run in and turns off features. You can call it basic enhancement, progressive enhancement, but I think it's a little bit more than that in that the application really understands, hey, what's the screen density, what's the screen size, how much width, do I have a virtual keyboard, do I have a real keyboard, do I have more editing layout space than before, and basically customize its layout. So we have about 50,000 editable InDesign documents. We round trip to the server and can edit any of them and then drop ship print those orders. And we've done this with a team of 5 people. So let's talk about mobile runtimes, because the browser runtime is really an amazing thing. And I can't say this enough. And I guess many forget it. But a browser is a native application. It is native code. But it is executing source. It is rendering source code that's interpreted via web standards. So web standards are how we write things, but a native application actually renders them. And that can be very fast. So fast, in fact, we just wrapped up a text engine, actually wrote a full text engine on Canvas for font and character-based layout. And it runs great. It runs great on any device. So the modern web, if you know how to take advantage of it, if you know where there are sweet spots, it can be very performant, and you can get great performing applications and create great experiences in it. It's just where you have to be very picky about where you do that and how you do that. I mean, most browser runtimes today are fully hardware accelerated. Everything goes through a graphics pipeline. Anytime you adjust a Z property or an XY property, you're doing translations in GPU. In basically, you're calling JavaScript to move things, but the actual result is occurring on the GPU. So native code is puppeting those controls and moving things around. It's easy to underestimate that. Also, JavaScript today is actually it's basically just-in-time compiled on the machine. It generates native machine code, and it runs at native machine speed. Your JavaScript is generating machine code in the browser. So it's a little hard to think about underestimating the browser, but really, browsers can do great things, and they can be used in a way to create great experiences, great apps. There is a performance ceiling with browsers, and it's something that you have to experience it to understand. But depending on the platform, depending on the hardware, depending on the operating system and the browser engine, there are different ceilings, and the ceiling height varies. It varies in height because, well, some browsers are more advanced than others in certain areas. Some have faster JavaScript, some have faster graphics. And so you have to be able to adapt to adjust to those. But what you don't want to do is you don't want to break the ceiling. And by breaking the ceiling, what you're doing is you're forcing the browser engine to go into a non-performance state from which they pretty much never recover. You end up locking up the page, you end up basically on some operating systems, on some WebKits, they actually dispose of the canvas object. They just kill it off. If you put too many pixels on a canvas object, it'll just turn off. It'll disappear from the runtime. And you have to be very, very careful to not exceed that. So it takes a different type of approach, a minimalistic approach, one where you're very cautious about what goes on canvas, what you're doing inside of the browser DOM at all times. The way we actually design the apps that we have, we end up mixing, and pardon the terminology, but I view DOM elements everything other than canvas, but canvas is a DOM object. But canvas is one DOM object that is really closely tied into the hardware GPU. So it's all GPU rendered. It's basically a bitmap image, but it's a programmatic bitmap image in that you can control it and you can use APIs to basically manipulate its surface and its data. But the combination and balance of the two ends up being really important. So inside of all the apps you'll see, we use tooltips. The tooltips are actually DOM tooltips. They're actually DOM text floating above a canvas object at a specific coordinate. All of our dialogues are our basic HTML templates rendered on the client. Any of our panels, any like photo upload or photo dialogues, those are all just HTML templates on the client. And we end up layering the canvas into that such that it creates a pretty seamless experience that you can get the best of both. You can get really fast graphics, but you can also get a very high quality editing experience regardless of what device shows up or where it's being run. And additionally, we've used Canvas to control the performance. You can, if you choose to render every animation frame, you can run the browser into the ground with just an empty canvas and a request animation frame. You really can. And so you have to be careful about when you choose to render, how you choose to render. Are you buffering up a series of calls to actually run those as an animation? Or when the user stops interacting with the surface, do you stop rendering? And so a lot of those things we designed into our product and our kind of core philosophies about how we build things. So in kind of a larger sense, the top half of the app is actually kind of DOM elements, HTML elements, position. The bottom area is actually canvas, but you see that tooltip floating? It has a kind of a floating kind of left above the tag. That's actually another HTML text element. And we actually have side panels that overlay the canvas object and also dialogues that go over the canvas object as well. So it kind of gives you a breakdown of how we treat the layering. So the Canvas API, it's probably my favorite, and it's personal preference. But I like it because it's very exact and it's very compatible. At the time, it was really thought of about as a programmatic rendering graphics engine. And it was given two distinct contexts. One, it can be used as a 2D context. That's how we use it, to draw graphics on a surface. But you can also make it, you basically turn it into the 3D context, which is WebGL. So you can actually run full 3D graphics through it and render through that 3D context. So Canvas is really a rendering layer. It ties into the GPU. It's hardware accelerated, and it's very fast across all platforms. And we use it for graphics. We do, as I said before, control the performance and manage performance of the canvas. And we only render based on a buffered set of interactions. So if you're not touching the machine, if you're not touching the page, it's a bitmap. It doesn't move. There's no JavaScript executing. As soon as you interact with it and roll over, we start rendering. And we'll render basic blocks on the canvas to make sure that the image is complete. So what you think you're looking at is you believe you're looking at a business card or a print layout, but what you're really looking at is bits and pieces of a static image being rendered to the front. And the experience ends up being pretty good. We also use a framework to manage that canvas rendering. We use Create.js and specifically the Easel.js libraries for rendering. The API is pretty well known. If you've done any sort of Flash development, it's the exact same API. So you can step into Canvas and HTML development and very quickly get things done. So in terms of libraries, one of the things we've had to do is to be very careful with what we choose, because there are implications with libraries, and there's a lot of great tech out there. Not dismissing any of it, but you have to be really careful with which tech you choose, because some tech it'll get you 80% really fast, but it makes the last 10% of a project nearly impossible. I've seen this with a couple frameworks. I've experienced it firsthand, but you don't know until you get there that you can't really finish the project with this technology, and you basically have to revamp and go in a different direction. I'm going to take questions at about 10 minutes at the end, so happy to answer those. So one of the things that I kind of talk about is side effects. Side effects are the things that really break web tech down, in that if one framework you're using manipulates something and changes the underlying data that another framework or another tool set is looking at, as soon as you get kind of an out-of-band side effect, you can basically break an app very quickly. So you have to choose libraries that are orthogonal in terms of they have no side effects. I can layer on Easel.js and Angular and not have any side effects with DOM manipulation, because one is targeting the canvas object and the other is targeting and restructuring DOM elements. Those two won't collide. But if you took Backbone and Angular, they will fight all day long, because one will change the underlying DOM structure that the other was expecting, and you'll get collisions. I view those as side effects, where you're trying to change the same thing. And they end up being pretty destructive, because frameworks are great as an abstraction. They provide a way to program an app, but a lot of times they don't allow you to get all the things you need. So sometimes you end up going down to, you're writing tags, you're writing elements, and you're positioning them as CSS, but the framework can fight against those. So you have to be careful about the tech you choose and the libraries you choose. We view it, we pick a library, it has a single purpose, and we don't add libraries into the project. If you can't do it with what's there, we take a look at the problem and see if we can't build something that works with it. And if not, we'll add one in, but we'll test heavily to make sure that there's no side effects with the library we're adding. And we've seen lots of side effects. We've seen side effects with one of our vendors decided to load their version of jQuery, which happened to have a whole bunch of appended libraries on the end of their jQuery that happened to interact and manipulate some things that we were working with. So we had to basically get very careful about sanitizing our environment, making sure the namespaces we were writing to weren't colliding with one another, and that we were getting the performance and not having any side effects from outside code. And the thing is, we write these engines kind of standalone, and then we deploy them to a server that is owned by somebody else. And so we're kind of going into a foreign environment, and we have to make sure that everything we're working with works cleanly under the tech they've chosen. Whether they have, two analytics libraries or whether they have other items that are executing in the background, we have to make sure we just work within that. So my rule is sort of the simpler you can make things, the better. The fewer libraries you have in a project, the better off you are. And if you ever have a person on the team who wants to add all the libraries, be very, very scared. I've had one on my team. It's very, very terrifying when somebody wants to add everything in, because it eventually will just become a giant heap. So frameworks for DOM. The goals is really to extract away the complexity of DOM manipulation. You want to be able to change the DOM in a performant volume way. You want to be able to change out the data to show an application, and that's really what an application is. Pages, they render a layout. That layout stays there. You can scroll it, move it around. It does nothing. It's just, once it's rendered, it just is kind of static. But with applications, you're manipulating that state. You're basically putting touch events in, mouse events in, and keystroke events in, and you're changing the data, which changes the view, which gives more feedback back to the user. And so being able to do that in a structured way inside of a framework is how I've worked for a long period of time. And I've switched between many different types of frameworks, and it's kind of an area that I know what I don't like, and when I see it, I flee. But typically, you'll have an MVC or MVVM kind of design architecture where you're basically manipulating a model, and that model is basically rendering out the view. Some user input is put into that view, and it's manipulating the model again, and you go round and round and round and round and round. And that's sort of the nature of things. Lately, there has been a lot of frameworks that are showing up that are virtualizing the browser DOM. And what I mean by that is they give you an API that you can manipulate, but the changes you make to that virtualized version of the DOM get buffered to the real browser DOM. And so what they do is they buffer up changes, and they only manipulate things just when they need to be manipulated, which makes them extremely fast. Because manipulating just JavaScript objects is extraordinarily fast. There's no rendering. But when you change the browser DOM, you have to be very careful about how you do it. Because if you change it, the browser engine has to go through all of the nodes affected and basically look for any structural breaking or restructuring or resizing, and then it reflows all the way out, resizes all the elements out to where your view is rendered. A lot of the frameworks take that away, and it's actually really nice. And I'll talk about a few of them in a minute. But really, you interact with, you do interactions. It changes the data, that renders templates, and the templates update the DOM, and then you go round and round from there. These are the 5 that I think are pretty important. This is my biased list. There's probably others other than this room would add to the list. It's not a end-all be-all. Vue.js is fairly new. It is my preferred framework of choice, and I'll talk about it a little bit more after this slide. AngularJS is hugely popular. It's a very good framework. It extracts DOM away, but it actually allows you to program bindings and layout in HTML. So it keeps templating in a templating-oriented language, and it allows you to render those out very cleanly from data objects and data models and view controllers. Very nice framework, very easy to build stuff in. I've built a few apps in it. I like parts of it. I don't like other parts of it. That's my personal take. React.js is very interesting. They were probably the first framework to really virtualize DOM elements and basically make batched DOM updating. So you make changes to applications written in React or components in React, and they buffer up changes and manipulate the DOM in a very minimalistic way. It makes it very fast, and the community around React has grown kind of leaps and bounds, much because the performance of the apps that are built with React are very, very good. Ember.js has been around a really long time. It has been revamped, and the latest version is actually looks really, really good in terms of the ability to create templates, do bindings, and the like. Everything you need to do, you can do in any one of these in terms of building an app. One standout is actually Polymer. Polymer is actually an attempt to create basically a new branch of web development called Web Components. And it's built on infrastructure inside of browser standards, evolving browser standards, which include Shadow DOM and also the web component APIs to allow you to build a really nice, clean tool set. But it takes a lot of the fragmented edges off of HTML and makes it operate much more like a component development model. Check it out. It's pretty interesting. So Vue.js. So I really love Vue.js. We've used it on 2 projects lately, and they have both shipped with less code than we had on prior projects. And by less code, I mean 2 times less code. And that's 2 times less code we've had to write, but also 2 times less code we've had to maintain. It has a very simple purpose. It binds models to views, and it allows you, it gives you an API so that if you change the model, the view is updated. The view is always in sync with the data model. And the data model can include very large arrays. It can include very large anonymous objects. Any type of value you can put into it, and it can actually manipulate templates into a very well-designed and well-laid out model. Just the example here should give you a little bit of a clue. But if you can see the curly brackets around message, standard templating. But that message object ties into this view object created in JavaScript in the center. That view object specifies the element demo, which is the ID on the div there. So it's taking a node of HTML and saying this element is a template, and this view is going to drive the data around this entire block of HTML. And so when you actually go in to say demo.message and you change the value of it, well, your HTML is instantly changed. All the way to the point where you can actually say input vModel is message. So what that does is it creates a binding between that input control and the data model. So if you manipulate the input control, the view is, the text is actually written out. And those two will actually, so this is the output on the right, those two will stay in sync with one another. This is a very simple, narrow example, but we found that it works no matter how big you create these templates. And the performance of it is actually really good. We've built some large things. The expressionary stamp engine that I showed you, that is all Vue.js. So we actually capture any sort of DOM changes on the form controls and basically push those into Canvas and manipulate the Canvas objects in real time. And we haven't had any real side effects with it. It is fairly standalone. It has 0 dependencies. It doesn't require you to add any external libraries. And it comes in at about 13, 14K. It's tiny. And it stacks really well. So you can organize them into, you create an array and you end up having 5 or 6 views. Those views can have a parent, and that parent can actually manage them. So if you want to show a list view and then a map view, and then you can make those kind of hierarchies very easily. And they also have a way to actually create templatized HTML. So I actually wanted to show you a little bit of it. So this one is a markdown editor. It's pretty straightforward, but this is the result. If I end up doing, so it's pretty standard. I type on the left in markdown, and I get markup fully written on the right. The HTML template is pretty easy. So I have an editor. I have the text area, which actually the whole value of whatever I type in on the left is the input. And then the div on the right it basically takes the input data and injects it as the HTML value. But it puts it through this marked process. So whatever the value of the left is, I want you to run it through this filter called marked and then output whatever the result is. So that this divider input, that basically means put the marked filter on the input data. In terms of JavaScript, this is the editor. Target the editor DOM element. There's only one input element, which is the input data value. And then you have a filter called marked. And marked is an external library that's pulled in and basically used here. CSS is whatever you want it to be. So there's no side effects between CSS can be any, your viewed layout can be anything you want. There's no componentry. It's simply binding the values together and creating the effect that you need inside of the app. But if that was it, I'd probably be like, oh yeah, big deal. But you can manipulate SVG values. You can end up building really nice slider components. And the componentry is somewhat silly. It's silly simple how it actually ends up working. So you end up, you're creating elements here where's the slider? So it's actually just looking at the image slider and basically creating the elements as needed. Take a look at the To-Do MVC. They actually have a To-Do MVC version. It's probably one of the fastest To-Do MVC apps, but it also has the least amount of code, which says a lot in terms of the approach that they're taking. And the code is actually rather interesting to look at from a editing point of view. But style it however you want. You're simply using it to create the structures to manipulate the view to get it what you need. It's a nice library. I would choose it for future projects and for other related work. And we depend on it on the projects we work on. So frameworks for graphics, this is kind of the other side of the coin. If you want to use any type of dynamic graphics, there's a lot of choices. Create.js is what we depend on in all of our work. We found it to have very good support cross-device, cross-browser runtimes, but also because it's dependent on the Canvas object, we end up getting a lot of mileage out of it. Even into the Android browser areas where mileage varies a lot. We get very good performance out of stock Androids running stock Android browsers in areas where typically other advanced graphical stuff just doesn't work. Fabric.js is another way to actually do canvas manipulation. The API is very clean. They end up having more componentry. It isn't just raw, hey, draw your graphics and other things. They actually have some editors for actually having controls to rotate objects or to scale objects. And they also have a pretty nice text engine inside of Fabric. Another one that is actually sponsored by Adobe is SnapSVG. SnapSVG is a modern version of a library that was licensed to Sencha, but it actually creates a very easy to use and easy to understand way to manipulate and generate SVG objects and canvas objects. And there's also D3. D3, if you've done any sort of graphic visualization work, it is basically a way to take bulk data and generate graphics based on that data. And you can actually, if you change the data structure out, the bindings will redraw a lot of the graphics. But worth checking out. D3.js is really interesting. It has both SVG and canvas bindings, so you can actually output to either or. SVG, really primarily SVG oriented. And then both Create.js and Fabric.js are canvas-based. So Create.js, we've had a lot of luck with it. And, I have done, I can say I've depended on it for a lot of the apps we create. And a lot of the things that you can do inside of, the canvas object. You can actually manipulate graphics. You can bend graphics. You can do very fast graphics, and you can also cache enable graphics. So you can cache graphics inside of the runtime. And so these all become little miniature canvases, and they're back-ended. So since the data inside one of these balls is not changing, why not just bake it to an image, create a sprite sheet, and then remap it in, and then just translate? That becomes a lot faster than actually manipulating the data. But you can also do bitmap filters, and we've used this a lot for manipulating imaging. So you can actually do raw image manipulation inside of the canvas object with inner image objects. And you can apply these filters. We've used the color filters and color matrix filters to do all sorts of manipulations on photographs. And then we end up sending it to we send the larger image to the server to basically do the manipulations in parallel. But you can also do translated objects, so it has a coordinate system that can keep track of objects. So the lines you see there are actually canvas drawn, but that's actually a button at the end, and it's tracking the animation. So you can do some pretty fast and interesting animations with it. You can also do kind of drawing and the like. And you can also do animated masks, filters, and all sorts of other interesting stuff. So you can do kind of, and again, once you stop doing interactions with this API, if you're not calling render frame, it's a static image. So you can build some pretty interesting things, especially relevant to the devices that we're seeing here at the conference and the tablets and the like. So yesterday, I actually open sourced this library. We had a series of issues with Canvas text. So Canvas text did not get the same energy that the graphics side of Canvas got. And what we ended up finding was Canvas text does not support kerning. It does not support line wrapping. It does not support, so multi-line you basically have to do yourself. Also, the baseline was kind of bogus. We weren't getting accurate baselines. We weren't getting accurate fonts. No support for ligatures, and no support for font measurement and font layout. So I kind of branched off on our team in this last build and actually built this text engine. So it's a text layout engine that basically takes an object and takes a text value and then renders it. It has full font support, and it's full independent font support, meaning it's not, it is independent of the browser runtime and the operating system. It is literally drawing the graphics directly. So you can do tons of interesting things, like you can actually put them on paths. You can put characters on paths. You can do characters that don't have word wrapping, that have character-based wrapping. But you can do some pretty interesting things with the library. But this is how you'd instantiate the code. Stage, add child, and then you create a new instance of text. You set the properties, and it will actually render. It will load the font in the background, and it'll actually render out to screen. So pretty excited to actually talk about this. I've been working on it for odds about 4 months and haven't been able to say much of what I'm working on, so this is actually the first time I've actually been able to talk about it. So development tools, let me actually go through kind of on the back office of how we actually work. One of the problems we have with 5 developers is you have to keep everybody in sync. And so you have to keep everyone's development environment in sync. We have some developers on Windows, we have some developers on Mac, but operating system wise, we want to have a tool set that works everywhere. So our build, we depend on NPM. Our build process, we use an NPM library called Gulp, which is a stream-based build tool set. And then we actually use TypeScript. So all of the code that we write ends up being an ES6 dialect with typing that generates ES3 and ES5 code that gets output to the client. And I'm going to walk you through these because they have a big impact from a team environment point of view. Because it's one thing for one developer to be doing fancy stuff with JavaScript. It's a completely different thing to have 5 people that are building interdependent code and checking in code over each other. And if you want to really slow down, not having a single build process and not having a compiler to assist you is a real drag on productivity. I mean, the compiling step mentally slows you down because I've got to do something before I can test. But the compiler can tell you so much about the code if you let it. And the compilers today are very, very accurate. TypeScript, I've been writing it for a little over 2 years. And we've been profoundly impressed with what Microsoft is actually delivering as a free open source compiler for JavaScript. So our build process, let me actually just run it. I'll show you what we do. So I'm in our build environment. I am in the stamps configurator, and what I end up doing is saying npm install. And what happens is we have a package JSON file that denotes every single one of our dependencies. And so in those 4 steps, that was pretty boring. That was a little too boring, actually. It was supposed to be a lot more. I think I have a cached build is what's essentially there. Yes. The libraries were pre-installed. That's cheating. So it goes out and it actually pulls in the TypeScript compiler, the Gulp compilation runtime, all the plugins we use for Gulp to do minification, catenation, and those libraries. It pulls them in, it installs them all locally, and then when we do a build after this finishes, it basically does the compilation, runs a local server, and gives you the resulting environment. And we actually have build tests within this compilation process. So we go through the process of making sure, hey, is this in check? Yes, that exists. This exists. So every time a developer checks out our tool set, they can basically go through the process of making sure their environment is exactly the way it is on everyone else's machine. And then you just type Gulp. And Gulp goes through, in this case, and I'll show you what it actually did. It goes through a process of cleaning out the target environment, so it basically wipes away the file system. It goes through and creates clean source directory, puts the source there. Then it basically generates a CSS. It goes through and compiles all of our TypeScript. It outputs libs into a separate directory and concatenates those. But at the end of the day, we end up with all the data's moved over, everything is clean, and everything is running in a browser so we can test locally. And so this is our local development environment. well, I don't really want to type that. So in effect, it gives us an ability to test and run everything locally. There's no server you need. You just need a desktop machine. And actually, this ties into our remote services, so we can broker data back and forth and get the documents. It's taken a while to get this right, but adding a new developer to our team is actually really easy. They just need to get in the command line, install some tools, and basically we kind of set them free. And because the build is compiled, you have to get everything compiling correctly before you check it in, which is a real gem, because two developers can't check things in that break one another. And it's very easy. The compiler will tell you every single place where you've made errors in your tool set, and the like. So let me actually show you some of that. So NPM generically is a package manager for Node.js. So the V8 JavaScript engine is installed as a library in Node.js, and we actually use it for all our tooling. TypeScript runs on top of it, Gulp runs on top of it, NPM runs on top of it. It depends on a locally installed JavaScript to execute. And then npm install will basically install everything that's denoted in the package. Gulp ends up doing async builds, so you can do asynchronous builds. It'll end up running tasks in parallel and then basically taking the piped results and merging those down all the way until it gets a final file system built out. So in the example I showed you, we basically compiled, concatenated, minified, we ran uglify. We spit out some reporting to the console to tell you how big the app is, and then we basically get a file system ready to run, and we run the web browser as well. So TypeScript, been about 2 years with TypeScript. It is a type superscript of the next generation of JavaScript, which is ES6. And it compiles back to ES3, ES5. Our Vue.js framework requires ES5. Our backbone version requires ES3. So we compile different targets on output JavaScript. And that also impacts which clients it actually runs on. So you have to be pretty careful about that. I view it as probably, it is excellent for team development. If you type your code, the typing is actually a developer API. So the more you type variables and objects, the more the compiler will restrict that area of code. So for sensitive areas of your code base, you can actually lock down. In our examples, we're very careful with our data models. We want to make sure that those are treated well. And the compiler will run through every flow of all code. So if it knows you're dealing with an object that is of a certain type and you do something outside of what JavaScript is capable of, it will just error out. It will tell you you're treating an array as an object, or you've set a Boolean to 1. And it will clean up a lot of things that they're small defects, but they end up adding up in terms of both performance, but also quality. Because if you've got more than one developer, you're dealing with a multi-dimensional problem of trying to get the code base into a better state. Again, we kind of use it as build validation. Before anybody checks it in, it has to compile completely to TypeScript. And actually, it has the biggest effect is it really removes our invalid builds from our testing. A lot of times when you're building JavaScript apps, if you're not using a compiler, if you're not using some sort of quality checking tool that understands the flow of types through an app or the flow of objects through an app, you end up with code that is technically invalid. It's an invalid, it's broken essentially. But you're going to test it anyway, and when you test it, you end up having kind of a wasted time. Our view is you can take those invalid builds out of the build process, and it cuts down the amount of time we test, and we end up spending a lot more time. We spend more time compiling, obviously, but we also spend a lot less time integrating code together, and a lot of our releases where we're batching code and kind of integrating, those are a lot smoother because we can identify where the error is. If you want to break an API, you simply go in and you change the type name and you compile it, and it will tell you every single line number and character space where your app is out and invalid. mean, that alone is a gem. And you can't really do that with JavaScript. It's not that you can't do it, it's just that JavaScript is so fantastically flexible that the runtimes will do anything with the input. It'll try to make sure, it'll coerce variables, it'll do all sorts of things at runtime. But if you can check it at compile time, you end up with a much better result. And we've had a lot of use out of it, and we've got a lot of mileage. It's probably, if I'd have to say, the two best decisions is Easel.js and TypeScript. Those two, I think I've counted at least 20 times where they've saved us from problems where we end up breaking the performance ceiling, or we end up doing something that we can't roll back, or just problems in our code base generically. So I can show you a little bit of TypeScript, and then we can switch over and ask some questions. So if you go to typescriptlang.org, they have this version called Play. But Play allows you to basically step through, and what you see on the left is TypeScript, and what gets generated over here is JavaScript. So the compiler is actually running in the browser here. The compiler is in the JavaScript engine of this browser, converting between these two windows. And it is live, so you can basically manipulate any of the code here. Let me actually kind of get to a different one. Well, simple classes. So I can say TED, and basically TED comes out the other side. But that's run through a full compiler and then basically output into the opposing window. But what we found was the quality of the output out of the compiler was good enough that if the compiler ever ran, if we ever found a case where we couldn't continue using the compiler, we would have started with the output JavaScript. So that was our basis for our decision, but we've never, ever switched from doing any type of, from not compiling things. But it also has great support for, what is it? It is generics. So it actually allows you to do arrays of int, arrays of strings, and actually passes those values all the way through all the code you write, and you get pretty fantastic output. For instance, if I was to go in here, and I can go into app source, fonts source. So this is our main. So we basically create a module called stamp, and then we begin to fill it with data on our configuration. And we end up doing tons of calls and tons of other stuff. Well, let's see here. Q&A. That's it. Thanks. So questions, I think there's 2 microphones if you just want to get up and stand up. Yeah, go ahead.
You showed how, what was it, Vue.js tied your models to the DOM.
Right.
And your inputs, I guess the input was tied to the model, which was then tied to the DOM.
Correct.
So I've got a bit of experience with Angular, and
yep.
It's kind of the same, especially with the filter as well. I mean, it looked the same. So my question is why do you like Vue better than Angular? Is it just because it's less code, or?
So the question is, why do I like Vue versus Angular?
Yeah, considering that what I think you...
Considering the example I showed is very, very similar
right.
To what you can do. What we have encountered is I can take a junior developer who knows JavaScript, and I can apply them to Vue, and I can get production-ready results that go all the way to the end of the project. With Angular, what we found was you have to have a really good Angular developer to get the project, well, most can get the project to 80%. Finishing an Angular project, we have found, is hard. That's very subjective. And it doesn't say anything bad about Angular, but Angular's pretty advanced, and you really have to understand what those intricate views and things are doing under the surface. It's a personal preference. I would just rather give simple tools to a team that can really finish all the way. And understand, my perspective is I'm a consultant. I'm helping a hired team complete the projects, and I did not have hiring ability to determine who was on my team. Now, if I was choosing a framework, I would hire Angular developers if I had an Angular project. But for this project, we didn't have that. And so we've had to evolve across using Backbone, and we had some speed bumps with Backbone because it can get a little complex in areas. It's a little bit black box-ish in areas. With Vue, we didn't find that was the case. Although we did have a platform limitation that Vue is dependent on ES5, so you really have to target ES5 compliant browsers, which is an IE9 plus problem. What do you do with IE8 when IE8 shows up and it blows up? But that's the nature of things. It's subjective. For a team that really understands Angular, go with what you know. Don't hesitate. And don't use my judgment about what I feel is right. It's what you can produce with the tools you have, not necessarily. And each team's different, to be honest. We sort of catered the team, like the TypeScript choice for us was more about you have to have, your code has to be this high to ride the ride. You know what I mean? Like when you're on one of those roller coaster rides and you have to be this tall. You have to get the quality of the code base to here to be able to check it in. And TypeScript gave us validation so that it leveled the quality across the team. So a team could be very, very productive. Angular is also hard to work with TypeScript. They have kind of there's a push and pull that they do in terms of the way the templating's done. That was another aspect of it.
Gotcha.
But it's great tech. I don't have anything, there's nothing bad about it. With the right team, it can do great things as it has shown time and time and time again.
Thank you.
You're welcome.
For the development tools that you showed in your presentation, they were all Node.js tools? Or,
That's correct.
Do you have any alternatives or any other development tools that you would recommend that are not dependent on Node.js?
Well, from a development point of view, the first tool set we started with was just Ant. And I'll be blunt, Ant's great. Ant's old, Ant's been hardened, Ant works on really obscure operating systems, and you get the same exact results. A lot of people would tell me that I'm archaic for even mentioning it, but it just works. So, I mean, there are so many build systems from Make to, I mean, you could go endlessly in that area. But what we wanted was everything based on Node.js. Because TypeScript was based on Node.js and it was deployed on Node.js, using Gulp and using other tool sets in that area kind of made sense. So that's what we did.
Because for someone who's just starting their own personal website, like I want to host it on a web server, but most of the times I can't get Node.js working on shared hosting sites.
Right. Most of what we're talking about is client development.
Right.
You can use Node to build server-side, but we don't use it for server-side. All of our server-side tech is Java-based. So it's, I mean, that is a pretty firm line in the sand. My client is Java. It's not Java, then it's Java. Let's turn it into Java and run it on the server. And so from a service point of view, everything I've shown is basically generating the front end. There is a mock server that runs over the app to basically get it operating on a local web server, but that's just the test environment. When we deploy to, I think they run Apache, and then I think they run other Java servers underneath it for app servers and the like. So,
All right, thank you.
No problem. Yeah, go ahead.
I saw your recommendation for TypeScript, and I was wondering, have you had experience with Clojure, which does a similar thing, but it kind of forces you to use comments instead of a different language to validate JavaScript? Right.
We have had some. The question is, have I had experience with Clojure, the Clojure compiler? I actually have. And one of the things that we ran into was the syntax for typing isn't in the language. And that's really the line that was sort of like, well, this will work, it'll give us the benefit of it, but at the time we felt we had a whole bunch of people coming who had syntax that was, well, syntax experience on the team was pretty high with typing with colon and type value behind, coming from ActionScript 3 and other environments similarly. They had a bent for using types the way that TypeScript. So there was kind of a decision was like, well, this is really close to what our team already knows. I'm pretty sure we could have done it in Clojure. I actually know we do run Clojure in the build process. When we run Uglify, we basically use Clojure to rename all the variables all the way through the app. So there is kind of a finishing compilation step, which is when we go through Uglify, it basically compiles it into, you really can't read these variable names, and it's really obscure when it goes to production. So it is technically in use on our project, but we don't inject source code into it or use types in that way. No. Yeah, question.
I'm curious a little bit about the back end.
Yep.
I realize this is more of a front end discussion, but when you say Java, are you developing your web servers in core Java, Spring, or Scala, Play?
That is an area that I don't interact with the teams on.
I see.
They provide us an API of services, and they basically blend them together with a tool set from Apache, and I can't remember the name of it, but it basically blends a service layer so they can deploy and take a single server and deploy it into a branch on request basis. So they can basically create a layered approach to how the network responds. Our apps end up are deployed to a static server, but then that service basically layers them up so they look like a big web server up front. There is a pretty big farm of servers that they run, but they're kind of, I can't think of the name of it. I'll look it up and I'll get the name to you, but most of the work is done with standard Java, and it's ended up rolled up inside of the app. Mm-hmm. I mean, they have a kind of a routing library, but I think it's, oh boy, I'm blanking. There's so many names for, it's Jetty.
Oh,
it's
Jetty.
basically Jetty. It's running an app server under Jetty and creating a small Java executable that executes the backend logic.
Okay.
So,
cool. Thanks.
no problem. And I would call that the end. Thank you very much for coming to the session today. Appreciate it.